Welcome back to our YouTube channel. Today we are solving an important coding interview question, finding the majority element in an array. This is a super popular question in company. We will solve it in two ways. First is basic approach using a hash map, and in second approach we will use the Boyer-Moore algorithm, which is super optimized method. So if you are ready, smash the like button and let's dive right in. Here the problem is described as given an array nums of size n, return the majority element. The majority element is the element that appears more than floor value of n by 2 times. You may assume that the majority element is always exist in the array. Here two examples are given. In this first example, we can see that the array contains the element the nums array contains the elements 3, 2, 3. Here we can see that 3 is occurring more than half the times the size of the array, so the output is 3. Similarly, in the second example, the output is 2. This is the first method and the simplest method to solve this problem. In this, we use a hash map to count the occurrence of each number. In this approach, we follow two steps. In first step, we loop through the array and store the frequency of each number in a hash map. In second step, we check if any number's count is greater than n by 2, and if it is greater than n by 2, we return that number. Let's see the working of this approach. Suppose we have a nums array with element 2, 3, 2, 3, 1, 2, 2. And in this approach, in first step we will iterate for each element of the array. So the first element is 2. We will see if this element is in the hash map. We can see initially we don't have any element in the hash map. So we will add this element in the hash map with its value. How many times it has occurred? Initially it have occurred only one time. So 2 will have the value 1. We will reach to the second element, which is 3. We can see 3 is not in the hash map. We will add it with the number of times it has occurred, which is 1. Similarly, we will reach to the next element, now 2. This element is already there in the hash map. So we will only increase the number of time it has occurred. So here we will add 2 on the place of 1. Now we will reach to the 3. 3 is already there, so we will increase its frequency. Now we will reach to the 1. 1 is not there in the hash map. We will add it with its frequency, which is 1. Then again we reach 2. We will increase its frequency. Again we reached 2. 2 is already there. We will increase its frequency. Sorry, here it will become 3, and now it will become 4. So we can see that in last the number with maximum frequency is 2, and the 4 which is 4, and we can see 4 is greater than the half of the array, so we have to return this 2 only. We have seen that this method is quite easy, but the only problem with this method is it offers a time complexity of big O of n and a space complexity of big O of n. Can we reduce these complexities? Let's check using the Boyer-Moore algorithm. Let's see the optimal approach. In this approach, we are using Boyer-Moore algorithm. This algorithm is super efficient. It works in big O of n time and big O of 1 space, which means it does not need any extra memory. It works in 3 steps. In first step, we pick a candidate and keep track of its counts. And in second step, if the count reaches 0, we pick a new candidate. And at the end, the remaining candidate is the majority element. We will return that majority element. Let's see the working of this approach. In this, suppose we have a nums array with element 2, 2, 1, 1, 2, 2. In our first step, we will initialize two integer type variable, candidate with value 0 and count with value 0. We will take the first element, which is 2, and check if count is 0. For our first iteration, count will always be 0. So we will update the value of candidate with this value only, which is 2 here. So candidate will become 2. Now we will check if this number is equal to candidate. We can see here the number is equal to candidate. So we will increase the count value by 1. Count will become 1. Now again we will take the next value, which is 2. We can see that count is not equal to 0 this time. So candidate will remain same. Now we will check if number is candidate. Number is 2 and the candidate is also 2. So we will increase the value of count. This time count will become 2. Now we will take the second value, which is 1. We see that count is not equal to 0. Now we will check if number is equal to candidate. Number is not equal to candidate. So we will decrease the value of count by 1. Now count will become 1. Again we will take the next value, which is 1. We can see that count is not equal to 0. We will reach to the next condition. We will check if number is equal to count. Number is 1 and the candidate is 2. Both are not similar. So we will decrease the value of count by 1. Now we will reach to the next element, which is 2, and here we will check if count is 0. Here this time the count will be 0. Now we will check if count is 0. Yes, we can see that count is 0. So we will update the candidate with this value only. This is 2. So we will change this value of candidate with this new value. Now we will check if number is equal to candidate. Number is 2 and candidate is 2. We will update the value of count. Now count will become 1. Now we will take the next element, which is 2. Check if count is 0. Count is not equal to 0. Now we will check the next condition if number is equal to candidate. Number is 2 and candidate is 2. Both are equal. Now we will update the value, means we will increase the value of count by 1. Now count will become 2. Now we have to return. Now we have reached the last of the array. There is no next element. So we will return this candidate value only, which is 2 here. Which gives us a time complexity of big O of n and a space complexity of big O of 1. Due to its reduced space complexity, this method is used optimally. Alright, that's it for today's video. Hope you found this explanation helpful. Let me know in the comments which approach did you like more, HashMap or Boyer-Moore. Don't forget to like, subscribe and share this with your fellow coders. See you in the next video. Keep coding and stay awesome.